Okay, so this is going to be the solution to the eighth problem in the grind 75. This is binary search. So to refresh our memory, um, basically this problem gives us a sorted array that's in ascending order and a target value. And if our target value is in that array, then we want to output the index at which that value is at. And some constraints, the nums int array will be a minimum of length 1. We can have very large numbers, um, but not exceptionally large. But even if they are exceptionally large, our solution will have a way to handle that. All integers are unique. That's sort of helpful, so we don't have to worry about um, finding duplicates. We just have to find that one. And then again, sorted in ascending order. So some pretty straightforward things. The first thing that I thought of was that you want to have you would do this like you would search a binary search tree. So you would look in the middle. If that value was less than the target, then you would then look at the upper half, and you would continuously look at the middle. But I had issues with knowing what part of the middle to reassign my pointers to, and I'll sort of explain what I mean by that in a little bit. So the first thing that I wanted to do was make an upper, which will be num.length minus 1. That's going to be our upper bound, and then our lower bound is going to be initialized to 0. Um, and this is a key thing that I missed. So while lower is less than or equal to upper. So if we're going to have these two, we can think of them as two pointers to two opposite sides of the array initially. Um, there are times where our array will have an odd number of values, and we will want to look at that middle value if our target is that middle value. So we can't bypass that, because originally I was thinking of something like this, but we need to check. For example, a more clear case would be if the int array had one element in it, and this was our condition, then it would, it wouldn't even enter this while loop. So we have to have a way to check, to have both pointers on one element so we can perform our desired operation on it. So the next important part is to get the middle, and what makes sense is to take the average of the upper and the lower, which technically in this problem you can do, but if I were to miss something, like say this was not here and I expected this to work for all integers of all sizes, then I would want to do something like this, which would actually be lower plus upper minus lower divided by 2. And while that looks sort of different, we can actually see here in our illustration that they're the same. If you just look at these two equations right here, um, basically, if we take this part out right here, let's make sure the size is right. Yeah. If we take this side out right here and then add it to that, then we'll get the same equation that we have here. But why do we do it this way? Why this unnecessary step? We do it because in Java, there's something called integer overflows. So the largest integer you can have is something like 2,141,000,000, something like that. And in the event that we have an element in the array that goes up to that point, or maybe two elements that, when added together, will go beyond that point, we don't want to have an integer overflow error. And if we were to take the average using this, the upper plus the lower, it's possible that we'll have two integers that will add up to something that is greater than that 2 billion something threshold. And so the way that we account for that is by using this equation right here, which will first take the difference of those two and then average that, and then just add our offset in afterwards, which would be the lower value. So that's how we account for overflow errors. Because problems in interview aren't really language specific, I'm assuming they probably would have something like this, because in Python you're not going to have this overflow error. But I think it's good to know why we do this, because I have seen this equation for taking the average in other places too. So that was sort of a long digression, but I think it's important to know why we should just use this to be safe rather than sorry. Okay, and then we'll sort of move on to the actual logic. So as illustrated in Paint in this illustration, this is sort of what we're going to do. So let's go over this example. So our target is 0, and where is it? Okay, our target is 0, right? We're going to initialize our upper and our lower to the upper part of the array and the lower part of the array. And these are going to be the indices. So upper is going to have an index of 7, which is nums.length minus 1. And lower is going to have an index of 0. Okay, we're going to calculate the middle by taking the average using this equation. So upper minus lower divided by 2 is 3.5, which gives us 3. Add that to lower, 0 still gives us 3. So I'm going to put middle here. Then we're going to do our checks. So obviously if the element at index 3 is our target, then we will want to return middle. But since that's not the case, we have to see where we went wrong. So is the element at the middle index greater than our target? It is actually. So what we're going to want to do is set our upper bound to the value, to the index right below the current middle index. Because we know that the element at the current middle index is not our target, and so we can just discard it and then keep the current lower. So then we'll go back through and we'll calculate our middle again, and this will be the average of 2 and 0, which is 1, and we will see that the value at index 1, which, let me actually update this. So our upper is now going to be set to 2, our lower is going to remain the same, and our middle is now going to be set to 1. And we see that the value at index 1 is -1, which is less than our target. And because of that, we know we can discount this index by making the lower 1 more than our middle, and that gives us the index 2 right here. And now that we've set 2 or lower equal to 2, we will again take the average, which the average of the upper and the lower is obviously 2, and then we will compare and see that the element at index 2 is correct. 0 is our target value. If it was the case that 0 was not our target value, then we would simply just go through the while statement and then yeah, we would go through the while statement and exit, and then we would return -1. So let's just write out the implementation really quick. I mean, it's basically what's there. So we're going to switch over to the LeetCode window, and we're going to say if, let's see, if nums at middle is equal to our target value, then that is exactly what we want. And we're going to return middle. Middle is here, yes, okay. Else if it's the case that, let's see, nums, the element at middle is actually, how did we want to do it here? If it's greater than our target, then we know that we're going to want to make our upper bound one less than the current middle. So that means upper is going to be equal to middle minus 1. And else, so this is the case that the element at index middle is less than the target. We know we're going to want to make our lower bound one above that. So lower is going to be equal to middle plus 1. Okay. And that should be it. If we go through this and we don't find a matching number, we want to return -1 as per the parameters of the problem. And that should be correct. So let's just run the examples. Semicolon, classic. Okay, and then maybe hit submit. Okay, so yep, that is the solution to what problem is this? Binary search. We sort of went off the deep end explaining some more nuanced things specific to Java, but I think it's important to remember these things so when they come up in interviews, you're not struggling to come up with an answer. So that's the solution.